Hello friends, welcome to this new video of this lecture series. This is a lecture 3, and here we try to cover the two basic concepts or two basic definition you can say. One is a timing graph, another is a timing arc. For this lecture discussion, I need you to remember whatever the discussion we done at the end of this last lecture. Why this is? Because in the last lecture, if you remember, we take a small portion of a big logic circuit. There is a two flops, two sequential flops, and they're connected with a very combinational path. And then there we define the data path, how the data path and clock path we can define. We point out those things. Why this is important here? Suppose small logic portion we taken from a big logic circuit that is given to you. Suppose from that we define the timing path. This is okay, but whatever the small logic portion we talked about in the last lecture, that you need to represent it into the timing graph. That you need to represent it into the timing graph. Because if you don't represent into that small logic portion into the timing graph, you cannot properly estimate the time of the every path. There is a several time based calculation, also graph based analysis, path based analysis. For now, that any logic portion, you can say any logic portion, we represent it into the timing graph, and that timing graph is actually a direction acyclic graph, which we called as a DAG. Okay, now come to the mathematical how you can represent the graph. So it's a very simple. Whatever the graph there is, this is representation of a vertex V and edge E, where obviously V is the vertices and E is the edge. Small v represented the corresponding to a pin or port of the circuit, and small e is the timing arc. That timing arc is also important concept uh, we'll cover later. Two cells you represented, and between there is a edge. There is a connection. Obviously, there will be a edge. Suppose this is a I cell and this is a J cell. So this can be a EIJ. The edge can be said it as a EIJ. That's why I said EIJ is a representation of the two vertices, representation of between the two vertices. Okay, the small logic portion, suppose you taken, this is a small logic portion, as assume that this is a small logic portion. I'll try to represent it into the timing graph, small portion of the logic into the timing graph. I need to understand the timing arc. What the timing arc definition says, it is defined as the relationship between the two pin of a logic gate. As I said, suppose this is one pin and this is one pin. So this is the one of the net arc, you can say. This is a one pin of the cell, this is another pin of the cell. What are the what is the definition, what is the relation of these two pin? This is a cell arc, you can say. So it is very useful for the STA tool to do the timing analysis properly. And there is a two type of timing arc, cell arc and the net arc. So as I said, like suppose this is the one point and this is the one point, so this is a net arc, and in between there is a 2 point. This can be represented as a cell arc. So let take it as an example. Take it as a one example, and I try to represent it this example as a timing graph with the help of the timing arc and timing path. Let's define this all cell. These are I1 cell, these are I2 cell, these are I3 cell, and also define those pins, A pin, B pin. This is also A, this is also B, and this is simple, you can say A pin or nothing. Then represent A1 as this, A2 as this is the I1 of A, and this is also a I1 of B. There is a I1 of Y. Why this is dot dot because this is a in between the cell. These arc are in between the cell. So this is the cell arc and this is the net arc. Red one is a net arc and blue one is a cell arc. These are I2 of A, sorry. And there is a A3. So this is a I2 of B. Then obviously they are the representation of the cell arc. So this is I2 of Y, and simply you can represent another as a I3 of Y, and then maybe this is a C point. So this is a whole representation of this small combinational circuit to a timing graph with the help of timing arc and timing path. When we talk about graph based analysis and path based analysis, this will very important role they can play. Thank you for listening this video with your patience. Thank you.